Hello, we're going to do linear inequalities. We're on section 1.5. Let's get started. We're going to review these and then explore further. So we're going to be talking about inequalities. We're going to first review how to just solve an equation. So we're going to explain why we do each step as we go. All right? So we have this equation right here, and we're going to move everything away from the letter M. So we're going to add the 9, and if we add it to one side, we must add it to the other to keep it balanced, okay? Keep it equal. This is an equation, and if you add the same thing on both sides, it does not change the equation. So I'll have a 3m left over, and 12 plus 9 is 21. So then we're going to divide by 3. Again, if I want to keep the equation equal, if I divide the same thing on both sides, it keeps it equal. We'll have m equals 7. Okay, that's how we do an equation. This is not an inequality, it's an equation, but we're going to use some of these things to the same things when we're solving inequalities. So let's do some experimenting here and explore inequalities. I've got an inequality here. I've got 3 is less than 4. And the question is, what happens if I add to both sides? What if I add 6 to both sides? Will it stay true? Will it still be an inequality? So here I got 3 and 6 make 9. Is that less than 10? 9 is less than 10. Yes, it is true. And I believe that if I kept adding the same thing on both sides, this is going to go up and this is going to go up, but it will never make it so that this right side is ever smaller than the left. What happens if I subtract something from both sides? So if I subtracted, let's say, 2 from both sides, I could get, let's see, this would be 1. Is 1 less than, let's say, that's going to be 2. Is 1 less than 2? Yes. But what if I subtracted enough to make them become negative? Would that change the inequality? Let's subtract something, make it a larger negative or more negative. So let's do like negative 7. All right, this side is going to be negative 4. And this side is negative 3. Is negative 4 less than negative 3? Is this a true statement? Yes, it is a true statement. Because negative 4 is smaller. It's further down in the negative, so it is smaller. So yes, it is true. It stays true. All right, so let's multiply on both sides. We're going to multiply a positive number. I'm going to multiply something like, I don't know, 5. Let's multiply by 5 on both sides. I'll get 15 on this side and 20 on this side. Is 15 less than 20? Did it change anything? Is it still a true statement? It is still a true statement. 15 is smaller than 20. Maybe there's nothing wrong. Maybe we can do everything with these inequalities the same as equations. So this time let's do multiply by a negative. I'm going to do a negative, I don't know, negative, let's do negative 3. Multiply by a negative 3 on both sides. I will get a negative 9 on this side, and I'll get a negative 12 on this side. Is this a true statement? Is negative 9 less than negative 12? It is not a true statement. This is now bigger than negative 12 because it's less negative. So we're going to have to make this a true statement, we're going to have to flip the inequality around. We need to make a special note. We flipped the inequality around because we multiplied by a negative, and then multiplying by a negative made the inequality false. So we need to keep that in mind, that when we multiply by a negative, we make the inequality false. And to change it around, we're going to have to switch the inequality around. All right, let's do some more experimenting. Let's divide by a positive number. And I changed my number here so we can get integers instead of rational numbers when we're done here. But let's divide. Let's divide by 2. If we divide by 2, this will be a 5 less than 10. Is 5 less than 10? Is that still a true statement? Yes, it's still true. All right, let's now divide by a negative and see if that changes anything. So let's divide by, let's do -5. This is going to be -2, and this is going to be -4. Is this a true statement? It is not a true statement. -2 is greater than -4. It's false. So to make it true, I'm going to have to flip the inequality around. We had to flip the inequality around when we did 2 things, when we multiplied by a negative and when we divided by a negative. So we need to keep that in mind. When we're multiplying or dividing by negatives, we must switch the inequalities around. So the rule is that when we multiply by a negative or we divide by a negative, we must switch the inequality around. Let's do some problems together. We're going to do numbers 1, 2, and 5. All right, let's do number 1. We're going to do 2 things. We're going to solve it and graph it, and it's provided the graph for us. So let's first solve this. We're going to do that first by distributing that. So we're going to have 5p minus 12 plus we're going to do that one next is the 6p. Keep the inequality how it is, and -89. Okay, now, our rule said that we could move things, add and subtract, no problem, to the other side. So we're going to add the 12 to the other side, and I'm also going to combine those. That's not going to be a problem. So I'll have 11p, keep my inequality. We're going to add that 12 to the other side, and we'll get -77. So let's divide by 11. Now, the trick comes, do I need to flip the inequality around? I'm dividing. Does division make us have to move the inequality around? It's only when we divide by a negative. That 11 is not negative, so we do not need to flip the inequality around. P is going to be less than, and when I divide that, it becomes -7. All right, so let's graph it now. I'm going to give us a little more room here. Move that down. All right, so if P is less than -7, we're going to need to put a mark somewhere around there on the -7. This is a less than, and it stayed less than down here. This says that what we're going to do is graph everything that's P. P is all the numbers that are less than -7, but it does not include -7. I don't have one of those little equal lines there, so it's only up to -7, but not including. So we're going to put an open circle on that 7. And the numbers that are less than -7 go this direction. I like to do this a little different. I like to make my arrows go like this. Other people have you shade on the line. I think it's easier to come up and over. And it's very visual then. We know exactly where our answer goes. There. All right, let's move on to number 2. Here's number 2. We're going to solve this very similar. We're going to move that over, and that's we're going to distribute. That's going to become 30p. We're going to distribute this, becomes -18. and we keep our inequality, and we're 162. We're going to add that over there. Remember, we can add to both sides. That's not a problem. We're left with a 30p on this side, and that becomes 180. Let's divide both sides by 30. Do we need to flip the inequality around? Are we dividing by a negative? No, we're not dividing by a negative, so we keep that how it is. And 180 divided by 30 is 6. So here we go. We're going to put an open circle on 6 for the same reason we did the last one. We're going to have an open circle right there because that doesn't have a little equal, and it says that p is less, so we're going to go towards the smaller numbers. And there's number 2. We're done. Let's move on to number 5. All right, here's number 5. Let's distribute this and this. Here we go. This is going to be negative 5x and negative 25. Here's my minus 2 and my less than. Now let's distribute. We've got negative 8x and positive 16 minus 1. Let's bring together our like terms. That's not going to change the inequality at all. I still have my negative 5x. I still have this, which is going to be negative 27. My inequality. My negative 8x comes from there. And we're going to combine that, which makes positive 15. All right, I'm going to move this over there and this over there. To bring that over, that's going to be adding the 5x to the other side, and adding the 5x to the 8x makes negative 3x. Bringing that over there, we're going to add the 15, subtract the 15, and we'll get negative 42. Now we're going to divide this by a negative 3. When we divide by a negative, an alarm should be going off, ding, 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 because we're dividing by a negative. When we divide by a negative, we must flip the inequality around. We have an x on that side, and negative 42 divided by negative 3 is positive 14. Let's graph it. I'm going to move this over and down a little so we have some room. We have 14. We have an open circle again because the inequality does not have an equal on it. This down here says that 14 is greater than x. You can read it the other direction and say x is less than 14. So we're going towards the less. We're going towards this side again. All right, now we're going to talk about compound inequalities. A compound means we're going to put two things together, and so we're going to put the two things together that are these inequalities. And I want you to notice that we have some words in there. There are some words in there, and the words are what make it the compound. We're putting two or more inequalities together. I've got the word and on this one and or on this one. And so we're going to do these, and I want you to make some observations about what and does and what or does in this equation. We're going to do number 9 and 11 together, and then we'll do a little bit more after that. So we're going to do 9 first, and we're just going to do it right here. It's on your homework also, but here we go. So if you'll get it out and you can do it with me. Here's this one. We're going to just do each one of those individually, but graph it on one graph is what we're going to do. So we're going to divide by this 4 here on both sides, and we'll have p greater than or equal to negative 4. And over here, we're going to subtract that 8 to the other side, and so we'll have p is less than or equal to 4. So we have 4 and negative 4. And I want you to notice that we now have these little equals there. And so instead of being an open circle, we will have a closed circle. Okay? This one over here says that p is greater than negative 4. So we're going to come up here, greater. And this one over here says that p is less than 4. So we're coming in there. Okay? Let's go and do number 11. We have the word or, so I want you to make an observation about what an or graph does. We had the and graph, and the and graph came together. I wonder what an or graph does. Does it go apart? Maybe they go both the same direction. I don't know. Let's see. So we're going to move that 8 to the other side by subtracting. So we're going to have p, the inequality stays that way, and we're going to have a negative 6. We have a negative 1, and we're going to add it to the other side, and so we're going to have p greater than or equal to 10. So let's see what happens here. I have the negative 6. These are going by 2s, 2, negative 4, negative 6. We're going to have an open or closed circle. A closed circle because I have the little equals line there. And I have a 10. We have 2, 4, 6, 8, 10. This one says that p is less than 6, so I'm going to come out like this. And this says p is greater than or equal to 10, so we're coming this way. All right, so I want you to make an observation about these graphs. I have an and graph, came together, and I have an or graph that went out. All right. You were asked to pay attention to the graph and what does an and graph look like and what does an or graph look like. And we concluded that an and graph came together and an or graph went apart. We did numbers 9 and 11. Now let's do, it says do 9, 10, 11, and 12. Let's go and do number 10 and then number 12. I want you to notice on this one does not have a word. There's no word in here. So I wonder if that is an and graph or an or graph. Let's do it and see if we can figure it out. So this negative 10 here, to get it away from that n, we're going to have to divide, but we're going to have to divide it on not just both sides, but all 3 sides. So we're going to divide by the negative 10 and the negative 10 and the negative 10. So I'm going to get negative 6 on this side, an n in the middle, and a 1 on the side, but an alarm should be going off. Ding, 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 because we divided by a negative. When we divide by a negative, we must flip the inequality around. This one has an equal on it. Don't forget that. Now we're going to graph. We have our negative 6. We're going to put a closed circle on that one. And we have our 1. We will put an open circle on that one. This reads, we can read it, we're going to read this part first. This says that n, and we have this open here, so it's bigger than the 6, n is greater than negative 6, so we come like this. It's coming in, and we have n is less than 1. So is this an and or an or graph? It is an and graph. Whenever you have an inequality where there's no, it's a compound, but there's no word in it, and there's 1 in the middle, it is automatically an and. It will never be an or. All right, let's do number 12. This is an or graph, so you might already know which direction its graph is going to go. Let's find out what numbers need to go on there. So for this particular one, we're going to move that 5 over to the other side by subtracting. So we'll have b is less than or equal to negative 10. We're going to move that 10 over by also subtracting, and we're going to get b is greater than negative 9. So we have two numbers to put on, a negative 10 and a negative 9. Here we go. Here's negative 10. It's going to be a closed circle on this one. And a negative 9 is, I'm sorry, that's not correct. Negative 10 is not right there. It's right there. And negative 9 is right there. And then, if we know it's an or graph, so we know it's going to go out. But let's just make sure we did our math right. This says that b is less than negative 10. And I need to make sure that this has got a little hole in it there. It's an open circle. And b is greater than negative 9, so it's going to go like this. So definitely it's an or graph, and it did go out. We did what we were supposed to. All right, let's review what we've done. We've solved and graphed inequalities. We noticed that whenever we'd multiplied or divided by a negative, we had to flip the inequality around so that it stayed true. And we solved compound inequalities. We had some or graphs and graphs.